Good morning. Welcome to World Forum for Women in Science. We are now in the technical session with the topic Advancing Sustainability Solutions, and I would like to give the word to our moderators.
Okay, thank you. Thank you so much for the World Forum Women in Science. Welcome. This is my turn. My name is Lisette Rodriguez. I'm a professor in Central America University. It's my pleasure being here. Greetings for everybody. And let me show you some things about, okay. Well, I would love to show you about the evaluation of new life potential in prefabricated building. The most important things to evaluate this kind of potential is these reasons: 30% of energy consumption, 30% of consumption of raw materials, and 30% emission from around the world is from the building, the waste generation. That is the reason that is my goal to try to discover new alternatives. The dependence, which results avoid dependence of fossil resources and the energy required for the transformation of raw materials into a new products. As we know, the buildings have two components. One of them is the consume energy and another resource, and for example, materials. According to the European regulatory framework, every building must declare almost zero energy expenditure in this operational stage. And for another part, the construction and reversibility is seen as a strategy to avoid impacts at the end of the life cycles. For this purpose, I'm interested in try to implement the level indicators. There is a new framework for the European Union. Since 2 years ago, they showed to us how to evaluate the sustainability in the construction sector. Overall, for the construction, design for the construction, which is means that the designer, the architects or engineering design the buildings to dismantle it in the future when the buildings get enough time. For example, the expectancy life it's over. One of these criteria is this easy of disassemble, easy of reuse, and easy of recycle. For this analyze, the methodology that I use is derived from ISO norm. In the life cycle assessment is a methodology which every scientific use from the last 20 years. We try to discover the footprint carbon in every stages. For example, A, B, C, D, and D means the benefits beyond the limit of the systems. And letter A, we analyze efficient building and optimize construction in nearly zero energy building, use of material and optimize circular value, prolongation of the useful life of the building and components, design for adaptability purpose, and design for the construction. I analyzed 9 cases of studies, but I present this day three buildings, three kind of concrete three buildings made for concrete, wood, and steel. A kind of this building is have 7 floors and a kind of this area, 1,000 square meters. Well, my hypothesis is this. I believe that the buildings can close the circle in a circularity way. The researcher hypothesis is based on the fact that by closed material cycle, and designing for the construction which allow materials to be tracked and recovered at the end of building useful life. It is possible to find the balance in a building life cycle equation and establish a maximum range of carbon footprints and balance the carbon in each stages. In this way, the end of the life of one building can be the beginning of the life of another one. This is an equation of life cycle, completely life cycle, but my hypothesis is present a new concept, new life. On the other hand, the new concept is notorious. New life that implies the evaluation of the potential to avoid impacts of the following concept according UN norm, reversibility and durability. We can see in this graph the stages and in the components of the principal elements of the buildings. For example, the structure, foundations, vertical structure, horizontal staircases, and envelope. This is completely the life cycle projection has been, excuse me for the viewing, has been made based of the data of embodied carbon estimating maintenance stage according to the recommendation made by design codes, as well as end-of-life scenarios have been foreseen, taking into account the durability and background study in the industry. The emission from the energy consumption of fossil resources has also been estimated following equation 1. The total carbon in the life cycle of the three buildings has been estimated. We can see the three kind of building. The first one is wood building, the second is concrete, and the third one is steel. When we apply the new life, the new concept, new life, the new opportunity to the building in order to avoid that this component will be in the landfill, the building can recover in a new life. And the footprint carbon reduce in a quantity half. We can see the life carbon footprint for three buildings in tones, considering the benefits to the limit of the system at the end of the life. When we compare two equations, we can see that this number, 1,200 of tons of footprint of carbon, and another. If we apply the new equation, we can reduce in a half. But how to achieve balance in the life cycle equation of building? In 2 points, the independence of the use of fossil resources in the life expectancy of the building, especially in the building contemplates energy generation. For example, this building, this one is one of the case study. This is a laboratory of energy in my university here in El Salvador. He was designed like a NZEV concept. And another one, the closure of material cycle through durability, reversibility, and recyclability with our concept that studied in the standard, and that guide the design process in order to avoid program obsolescence. But in the conclusion, the evaluation of circularity factor provides feedback for future design exercise that is allowed evaluating the design from the potential for the construction, which implies not only thinking about how it will be built, but how it could be dismantled in a controlled way to recover the largest number of components according to the wear they have. This mean that we have to think in the about the buildings in not like a static things. We have to think in buildings like a system which recovered raw materials and avoid the trash and avoid to get new materials because this is one of the big problems nowadays. For building new buildings, the people need more resources, and that is my message. I appreciate. Thank you very much. I think it's I was quickly, but 10 minutes kind of. Well, the next presentation maybe is okay. The next presentation is, well, I don't know if you have any comments or questions. Okay, maybe we will continue here. Carol, Nathia, Persha, and
Yep.
Amruta. Okay. Nathia, you are the next.
No, our next presenter is Parshana K. Monogram, I think from University of Malaya, Malaysia.
Hi. Hi, I'm Prashana Manogran. Okay, I'll share my screen. Can you all see my screen? Full screen?
Yes.
All right. All right, I'll start now. A very good morning to everyone. I'm Prashna Manogran from University of Malaya, and I'll be talking on my research topic, which is development of self-assembled nickel carbonate hydroxide hydride electrodes for supercapacitor. So in this presentation, I'll give a brief introduction about my topic, followed by problem statement, research objective, methodology results, and conclusion. Excessive emission of carbon dioxide in the atmosphere together with other greenhouse gases have resulted in a lot of impacts on the environment, which have urged researchers worldwide to transit from the usage of fossil fuels into renewable energy resources in line with our Sustainable Development Goal 7 to produce a clean and affordable energy. But the high uncertainties of renewable energy resources requires an energy storage device that has high power delivery together with high energy storage capacity to support during peak demands and also when energy supply is low. But the established energy storage devices like batteries and also supercapacitors, they cannot do both. For example, batteries, they can store a large amount of energy, but then they cannot release the energy fast or recharge fast. Meanwhile, supercapacitors, they can release energy very fast and also can be recharged within seconds. But they cannot store a large amount of energy. Therefore, to resolve this issue, we have come out in a hybrid solution by combining the advantage of supercapacitors and also advantage of batteries to produce supercapacitor, where this device can store a large amount of energy at the same time they can also be recharged fast. This is how a supercapacitor looks like. Since I say it's a combination of batteries and also supercapacitors, one electrode will be made up of a capacitive type electrode representing supercapacitors, and the other will be made up of a battery type electrode representing batteries. In this work, I will be only focusing on the fabrication of the battery type electrode. Mainly, I'll do a binder-free nickel carbonate hydroxide hydride based battery type electrode because I want to avoid the resistance caused by binders, which can result in lower electrochemical performance and also cause material degradation over time. And nickel carbonate hydroxide hydride based electrode material is chosen because this has high theoretical capacitance together. The wettability due to the presence of carbonate and also hydride can increase the electrochemical performance. The research objective of my work, I'll list it into 4. First, to determine the most suitable metal precursor to precipitation age ratio to form the nickel carbonate hydroxide hydride electrode material itself, followed by to investigate how different type of nickel form is actually the substrate used in the supercapacitor tree, affects the electrochemical performance, to assemble and study the effectiveness of the formulated electrode material for practical application, which is supercapacitor, and last, to characterize synthesized electrode materials using various analytical methods such as PSAM, HRM, XRD, and more. So in my methodology, I will divide them into 2 parts. The first part is actually synthesis of the electrode material, which is nickel carbonate hydroxide hydride using hydrothermal method, where here I will manipulate the metal precursor to precipitation agent ratio to optimize the production of the product itself, and then I will move into optimization of the nickel form. So this is how an hydrothermal method is done. I will first mix the metal precursors, which is nickel chloride hexahydride in this case, with our precipitation agent, stir it for 30 minutes, and then transfer it into an autoclave where, to produce a binder-free electrode, we will place a substrate, which is nickel form, into the autoclave before adding in the solution, and then put inside the oven for heating for 6 hours at 140 degrees. After the hydrothermal process, it will then be naturally cooled down, washed, and dried. Now, going into the second part, once we optimize the nickel carbonate hydroxide formation, we will then optimize it in terms of nickel form selection. Here, different types of high porous nickel form will be selected to study how change in substrate affects the electrochemical performance. And then this will then subjected to different characterization like electrochemical, which is very important for energy storage devices, followed by structural and also physical characterization. The results I've obtained so far for the first part is 0,1. The second part will be 0,2. From the XRD I have obtained, it shows that we have successfully synthesized nickel carbonate hydroxide hydride, and even though we change the ratio between the metal precursor and also precipitation agent, the product does not change. This is maybe because of the molarity of urea was kept constant. If let's say we were to increase or decrease the urea concentration, then the product might differ because it directly relates with the hydrolysis of the urea during hydrothermal process. In terms of the morphology, it was seen that when we increase the urea concentration, the ratio, it shows that the morphology or the nanoflakes that has been produced, it's more flakier compared to 1:3 ratio. And it was found that the more flakier nanoflakes can result in the increase in the diffusion pathway, which can affect the electrochemical performance. We will require a shorter diffusion length so that we can enhance the energy transfer kinetics. Charge transfer kinetics. So we will then subject it into the electrochemical performance, and it was found that from CV, which is cyclic voltammetry, we also subjected into galvanostatic charge discharge test, where this too is the main for electrochemical performance. It was found that all the product exhibited a clear redox peak, indicating and also confirming it's a battery-like behavior, which says that indeed what we produce is a battery-grade electrode. And then it was found that the linearly increasing relationship between the current, peak current, and also the scan rate says that we have excellent capacitive behavior. And also from the calculation, it was found that the ratio 1:3 and also 1:4 reflects optimized electrodes. To confirm the results, we did GCD test, which is galvanostatic charge discharge. It was found that the symmetric and non-linear curve represents a fast and reversible Faraday storage mechanism. And also from the calculation, it was found that 1:3 ratio has high rate capability, meaning it has higher stability with competitive specific capacitance and also energy density that will be suitable to be brought forward to the second system. So in the second system, when I said we will change the nickel form of all high porous type, from naked eyes, you will see that everything looks the same. But through FESAM, we can see that NF1, which is nickel form 1, NF2 is nickel form 2, and NF3 is nickel form 3. We can see that NF1, it has a cylindrical branch with a very rough surface morphology. Meanwhile, NF2 has a flat branch with a very smooth surface, and NF3 has a flat surface with a very rough surface roughness. And on the other side, we can see that the directly self-assembled nickel carbon hydroxide hydride on these nickel forms, it was found that the NF3, the third nickel form, has the most dense deposition because of the structure itself. Roughness can increase the amount of particles deposited because of a better grip, and also a flat surface. It is beneficial for the singular and also small nanoflakes to form a network for the larger particles to be deposited on them. In the electrochemical performance, it was found that the shape of the curve retained even though we change the substrate, indicating that substrate specification does not affect the nature of the active material, but it affects the specific capacitance and also energy density because it affects the amount of active material has been deposited on the nickel form. Because more active material, more redox reaction can happen and more charge capacity. Higher charge capacity, it is directly proportional to the amount of energy it can store. So it increases the amount of energy stored also. So from the GCD results, it was found that the NF3, the nickel form 3, which has a flat branch with a rough surface, gives us the most optimum electrochemical performance and also retaining the symmetrical and also non-linear curve, which is favorable for a battery-like electrode for a high power density with high energy density requirement. So to conclude, it was found that the nickel carbon hydroxide hydrides of 1:3 ratio is the best performing for the first part, and it was found that metal precursor to reducing agent ratio does not affect the product of hydrothermal but affects the morphology of the product. And then nickel form type have a significant impact on the energy density and also the specific capacitance because it directly affects the deposition of the active material. It was concluded that the nickel form type 3 is the best performing for the second part, and it was perceived that the synthesized sample is a potential candidate for supercapacitor application because it has high power density and also high energy density. That's all from me. Thank you. These are the references I used.
Thank you very much. Prashana Manogram, she's a researcher at the Department of Physics, University Malaysia, development of cell-assembled nickel carbonate hydroxide hydrate electrode for supercapacitive. It was very interesting. Excuse me that we have not present you. The next colleague, researcher, but before, I don't know if somebody have some questions and comments.
For now, in the
Well,
question and answer section, there are no questions, but if there are, we can answer.
to the final. Okay, thank you. Thank you for telling me. Well, the next presentation is from Amruta Muralida. She is a student from College of Engineering in India. Amruta, are you here?
Yes. Yeah, I'll
Can
share
you
my screen.
present, please? Her presentation is All Driven Precision, Agriculture and Sustainable Food Products. Thank you.
Thank you. So I'm Amrita Muralidhar, and I will be presenting on AI-driven precision agriculture for sustainable food production. With the growing world population and the challenges posed by climate change, there is an urgent need to transition towards data-driven practices in agriculture, and that is what the future is of agriculture, a more data-driven approach. And this is where precision agriculture and artificial intelligence helps for that, as it is quite revolutionary in this transformation of traditional farming to a more technological practice, as this optimizes resource consumption and minimizes the environmental impact while also servicing the global food security issue. AI-driven precision agriculture offers a solution to these uh, challenges of the climate change and the need for more food production by using real-time data gathering and analysis. So these are some of the use cases of artificial intelligence in agriculture. Crop monitoring, predictive analysis, irrigation, weed detection, soil health, livestock management, using drone technologies, and more. So this is kind of a question. In this data set of leaf images, manually identifying which disease has which disease, which leaf has which disease is quite challenging for manual labor. But of course, with experience, he would be able to tell, but it still is laborious and quite expensive because you will have to employ a lot of laborers to go through the leaves of each plant, and it's not just one plant. In agricultural farmland, there would be a lot of plants, so to go through each of the leaves there would be quite tedious. But this could be solved by automating it with cameras that are there on drones. They will gather the images, and our model, LSTM based model, would be able to classify which disease is on which leaf and later give the predictive measures for it. So the artificial intelligence in precision farming supports the following sustainable development goals. SDG2, which is zero hunger, it helps optimize the crop yields, minimize resource wastage, and improve food security by precisely monitoring and managing crop growth. SDG3, which is good health and well-being. By utilizing these tools for disease detection, farmers can promptly identify and respond to plant diseases and pests, so it reduces the need for chemical pesticides. This promotes healthier ecosystems, reduces environmental pollution, and minimizes health risks associated with pesticide exposure for both farmers and consumers. SDG 6, which is clean water and sanitation, irrigation systems optimize water usage by delivering the right amount of water to crops based on the real time data such as soil moisture levels and weather forecasts. This therefore minimizes the water wastage and helps conserve the resources, contributing to sustainable management practices. SDG 13, which is climate action, this automating enables a more efficient use of resources such as water, fertilizers, and energy. Hence, this reduces the greenhouse gas emissions and the overall carbon footprint associated with conventional farming practice. SDG 15, which is life on land. Monitoring systems can track changes in land and soil health and biodiversity. This facilitates the sustainable land management practice. So it promotes minimizing soil erosion, preserving habitats, and protecting biodiversity, thereby contributing to the conservation of terrestrial ecosystems. Finally, SDG 17, which is partnerships for goals. Collaboration among governments, agricultural organizations, technology companies, and farmers is essential for this adoption. So, this fosters the partnership and knowledge sharing initiatives by stakeholders. This collectively works towards addressing the global agricultural challenges and achieving the SDGs. Our long short term memory based model helps monitor crop health, soil conditions, weather patterns, and pest infections accurately. So it's an all in one model. This is the activity diagram. We start with monitoring the soil conditions, and based upon the results, we proceed to match the crops. So to determine which crop would be suitable for this pH level in the soil or the moisture content there. And then plantation, after which our monitoring process is started. This is a loop. In this, we continuously monitor the crop health. If it is okay, then we go towards, if it is not okay, then we go towards problem identification. Here we check if pest is detected. If it is, then apply pest control measures through perhaps drone technology or even manual alerting using GSM-based modules. If there is no pest, then we check if the crop is facing any deficiency, like nutrient deficiency. If it is, then go towards applying more nutrients. And finally, the loop is stopped. This is the component diagram. We have four components here: primary user, which is farmer, and we have four input modules: the pest monitoring, weather monitoring, soil monitoring, crop monitoring. All of these act as input modules. So the input from this is fed to the LSTM module. This is the processing component. In this, the decision is made and sent to the action modules, which is pest control, optimization, nutrition optimization, irrigation optimization, and planting optimization. So these make the enact the actions. We have four profiles here: the farmer profile, which is the user profile, and data gathering profile, the monitoring system, and the components of that. And we have the processing profile and the warehouse profile. This is our deployment diagram. We have three nodes. The first node is the user device, which is the farmer device or even a cultivator device. This requests data from our server node. The server node has the processing module and the database, which stores the sequential data that arrives, and also has access to the external node, which has the weather API and pest control API. So from all these, the decision is made by our server node and sent to the user interface, the user device, who might then take action. This is the sequence diagram here. So the first, the soil monitoring is done, and then the soil monitoring requests for a decision, and the decision arrives, and that is sent to the user interface, and weather is checked by weather monitoring module, which is then sent to the decision making module for information, and then pest control. After that, crop health is continuously checked. Crop monitoring is done after every decision, and then nutrient deficiency is checked when pest results, when pest infestation status is shown. Nutrient deficiency is checked. If nutrient deficiency is there, then we send to the warehouse module to supply nutrients, and later the loop runs continual monitoring. So this is the result of the training data on weather prediction. So the loss is quite less. The loss is 0.05%, as shown in the graph here. You can see that the true value and the predicted value are quite close. This is the same on testing data. Again, the loss is very less, and the true value and prediction value are very close, so they're almost overlapping. This is on soil prediction. We have considered four attributes here. And again, based on the training and testing of here, matching different attributes, we can see that the loss is 0.3. The loss is 3%, which is still less. And the accuracy is 99.7%, which shows that it is quite accurate. So the conclusion and future work is that despite the benefits associated with it, there are still challenges and a few ethical concerns regarding this. And we've broadly classified them as two main types: accessibility challenge and ethical concerns. In accessibility challenges, we have resource limitations. So that is inadequate access to technology because small scale farmers would not be having the access to employ this as of now, and lack of infrastructure because we do not have vast agri-tech companies set up that are willing to do and provide this for large scale farmers. And solution needs are cost-effective technologies. Again, the server requirements and the processing requirements and user-friendly interfaces. We don't have multilingual interface so far, or interface like that that could accommodate large-scale farmers. And localized AI applications. Again, we do not have specifically tailored solutions for one particular region. It's very general so far. Ethical concerns would be the data issues like the ownership complexities, because the data generated are quite large amount here. So this is big data, and who has ownership to this big data and who has access to this data is one of the concern. And governance and security, there is need for um, transparent regulations and security, cybersecurity protocols that safeguard the big data generated in this. That's it. Thank you.
Thank you very much, Antaruta Muralida from BMS College of Engineering in India. Well, the next presentation, the next colleague is Nisaf Slaimi. Are you here, Nisaf?
Hello.
Hello. Okay, Nisaf is engineer in Higher Institute of Urban Planning, Environment and Construction, Tunis, Carthage University, Tunisia. The presentation is STEM game-based learning approach and sustained water management and civil engineering practice. Okay.
Yeah, thank you. Just I am Nisaf, graduated engineer from ISTEP institution. Yes, I will share my slides right now. Can you see my screen?
Yes.
Yes. Okay, thank you to hosting me here in this World Forum on Science. I present research about STEAM games-based learning approach to sustain water management, especially in civil engineering practices and civil engineering field. We know that the background is here of the study is created according to the comparative review between traditional learning and innovative learning. The traditional learning methods that struggle a lot to offer students immersive experience that can mirror the complexity of real-world scenarios. So this comparative scenario stimulate the interactivity to design educational purpose, to design educational tool in order to emerge it as a promising solution to bridge a pedagogical gap, especially in civil engineering complexity and the understanding um, of such topics. So we know that in the face of water management and water challenges around the world, water have been a big issue. How we can adapt our programs, our educational programs, to incorporate such a global issue via innovative approach. The problem really is that multiple informed decision in stimulated water rated scenario lacking a lot of awareness and education, and also the potential to enhance such a social and cultural interaction in same time is very challenging to promote the development of argumentation skills, or we call green skills, and collaborative learning between students and the class. So how we can really innovate and create tools in order to address such a problem, and to engage and to sustain also all the application of sustainable water management principles for students and also for future generations. We create a framework that is based on three dimensions: to learn and to play, also to stimulate and to solve water issues. In this framework, impart knowledge and skills crucial for sustainable water management, and the concern is surrounding water scarcity, especially in Africa and around the world, and what are the environmental impact that we can approach for this educational tool. From this overview statement, we explore multiple dimensions that the game-based learning can offer in advancing such sustainable practices or water practices. So the methodology, according to this framework, based on a mixed approach of the game-based learning, that we can use it among students or in civil engineering field, is the background of the methodology based on insights from students' perception and their engagement level. We observe a lot of lack of green skills among them, a lot of lack of social cultural awareness, STEAM engagement, low STEAM engagement, and low of connection and collaborative learning, especially on those statements or insights create a huge gap. So how to assess such a mixed approach? By motivation, by engagement, by creating or stimulating student curiosity and reflection, and by engaging them to understand the complexity and applying decision based on real data scenario of multiple area that can sustain water management rather than imaginative scenarios. So as a result, we for this methodology, for this mixed approach, we analyze a multiple dimension of the landscape of water challenges, especially in civil engineering field. We say that there is water scarcity, there is a marginal and superficial understanding of student engineers in this field. There is overburned water supplies and misconception of water use, the depletion of groundwater, disruption of local water cycles, especially, and many obstacles faced, especially to bridge partnership and collaboration in this field, in this educational field. So as a result, we create a tool, an educational tool, STEAM-based learning, based on this step-to-step guidance in order to achieve our qualitative approach based on qualitative insights from students. And this approach, this framework is created based on a game time of 45 minutes that the player can select problems from multiple problems, and then they extract cards in three main issues: water scarcity purchasing, water quality, and pollution, and water supply, how to supply water and how to supply the water system. When they extract the problem, they will extract also the functional card according to the problem to solve this problem. The functional card here is based, like a monitoring card to stimulate the curiosity of the player, of the engineer, in order to reflect on the problem and get a solution. So there is a process for the functional card. We invest in technology. We choose an area where based the process or the method of sustainable water management. When we purchase this area, we select an alternative how we can manage the water use, and then we calculate the carbon footprinting, the consumption, and then we interact with other players in order to create such a collaborative landscape between a player. Then they will have the solution, and then we'll get feedback from each others. So we made this like research activities in order to stimulate multiple people, different age and different categories. Then we create a collaborative game based on a specific building that sustain and the water cycle and the water engineering management based on multiple data related to this building scenarios. So what we are going to do from this research is to value this research and to implement it in real world, especially in civil engineering fields. We can, from this tool, we can develop green skills and build such a kind of collaborative learning environment between students. We can ensure that everyone have the quality to access to such a tool and make an inclusive education in sustainable engineering. And integrating such a tool can really foster a qualified educational system among the university or the schools. This solution is scalable 100% for multiple civil engineering fields. Thank you so much.
Thank you, Nisaf Salemi from Hagar Institute of Urban Planning, Environment and Construction, Indonesia. The next presentation from Carol Nowania, and she is a PhD candidate at University of Cape Town in South Africa. The title is Investigation and Valorization Routes for Carbon-Rich Waste Streams, particularly carbohydrate-rich food waste for bioenergy production. Carol, are you here?
Yes, I'm here.
Okay.
I'm going to share my screen shortly. Can you please confirm if you can see my screen?
Yes, of course.
Can you see it now?
No, not
No.
yet.
Okay.
Yes, we can see it now.
There you are.
Okay. All right. Good day, ladies and gentlemen. My name is Carol Zetungwenya. I am a PhD candidate from the University of Cape Town. Today I'll be presenting to you a portion of my PhD thesis, which looks at the use of carbohydrates-rich waste stream for renewable energy production. South Africa has shown, South Africa has shown a growing interest towards the development of a bio-based economy. This was supported by the Department of Science and Technology in a bioeconomy strategy that was developed in 2013. This strategy basically supported the use of biomass in different process technologies for the production of different valuable products that can potentially be generated from waste. It also supported the implementation of biorefineries for valorization of waste to produce valuable product that can potentially contribute in economic activities. Over the years, there has been various policies that have been developed to support the establishment of a bioenergy sector in South Africa. It was first highlighted in 1998 in the White Paper and Energy Policy, whereby the government acknowledged the need for a diversified energy supply in South Africa. However, with the high fuel cost as well as increase in carbon emission during the generation of fossil-based energy, it further motivated the need for a renewable energy policy, which was adopted in 2003. However, the lack of policy implementation, political will, there's been very minimal progress towards the development of a bio-based economy in our country. South Africa is one of the signatories of the Paris 2016 agreement, which has instilled or reignited the interest of developing bioeconomical activities as well as reducing climate change. As a result, the Integrated Resource Plan of South Africa was revisited to accommodate and acknowledge the need of using biomass for renewable energy production. The South African government does acknowledge that implementing waste-to-energy technologies can potentially increase the economic status of our country, which will enable different industries to generate their own energy, which will then therefore minimize our dependence on fossil fuel and the national energy grid. So my project basically focuses on identifying suitable feedstocks for agricultural waste, suitable feedstock for renewable energy production. So agricultural waste is one of the largest waste stream that is currently disposed into landfill and has been identified by various researchers as a suitable feedstock for renewable energy production. However, the use of agricultural waste stream is associated with a lot of legislative issues, such as most of this waste stream are used as food sources, and also they do contain complex carbohydrates, which makes it very difficult during fermentation, and it presents all sorts of challenges. So the challenges now presented by agricultural waste stream has motivated researchers to look at alternative waste that can potentially be used as feedstock. This basically then includes carbohydrate food waste that is one of the largest amount of waste that is disposed in landfill in South Africa. So part of the food waste that is disposed into landfill includes confectionery waste. Confectionery waste now is a sugar-rich waste streams that contains significant amount of easily fermentable sugars, and when disposed in landfill, they cause all sorts of environmental challenges. That includes generation of leachate that can they can have a harmful impact on human health. A lot of industries in South Africa there are a lot of industries in South Africa that produce confectionery waste and currently dispose it into landfill. So my project now looks at minimizing the amount of waste that's currently being produced and disposed into landfill towards alternative valorization technologies such as biogas production, biofuel production that can potentially be used to fuel the transportation of confectionery products, or also can be redirected back into the confectionery plant to offset the plant's energy requirement. So in that way, the plant can be enabled to generate its own energy and minimize the amount of waste going into landfill and potentially reducing their carbon footprint. Globally, various companies have looked at different strategies to reduce the amount of waste they produce. For example, you have Nestle in the UK. Nestle in the UK has collected all the waste that they generate and put it in an anaerobic digestion system that by mixing it with the wastewater that's also generated in the different processing steps during manufacturing, the waste collected, the solid waste collected is mixed with the wastewater, from which is then added into an anaerobic digester to produce biogas, which is also then recirculated into the confectionery plant. This has allowed Nestle in the UK to offset their overall energy requirements by 10%. Mars Chocolate in the UK has been able to also reduce their overall carbon footprint by reusing some of their waste into and by implementing bioenergy generating technologies to offset their overall energy requirement. So now my research study, the objective of my research study focuses on using Zymomonas mobilis. This is a bacteria that can ferment high sugar-rich waste streams to produce high bioethanol yields, biobutanol production from Clostridium saccharobutylicum fermentation, as well as biogas recovery from anaerobic digestion. This is all aimed to assist in a decision-making tool to allow policymakers and waste producers and different industries that produce carbohydrates-rich waste stream to choose the most ideal process technology to process their high carbohydrates-rich waste stream to generate energy that can potentially offset their overall energy requirement and reduce their carbon footprint. So for the purpose of this presentation, I will start by focusing on bioethanol production by Zymomonas mobilis. So for bioethanol production, I looked at different waste stream that is produced by one local confectionery waste plant that is hard candy, chocolate, marshmallows separated. So basically, we take the sugar waste stream, feed it into the Zymomonas mobilis, which breaks down the sugars and produce renewable energy. During the fermentation process, we do monitor the utilization of the individual sugar components within the waste stream and also the growth and as well as the ethanol production. So initial analysis of the sugar basically showed that it showed that the confectionery waste is really high. I am having challenges with my slides. Apologies for that. It showed that the confectionery waste are really high in sucrose, which was then used as a base case study. So we used store-bought your chemical sucrose to analyze the growth and ethanol production of Zymomonas mobilis, from which we were very interested to see that the microorganism was actually very able to use all the sugars to use sucrose as a carbon source, but the amount of ethanol produced was rather very low. Further investigation revealed that the enzyme that is responsible for sucrose hydrolysis is known to have two active sites upon sucrose hydrolysis. The second active site is activated, from which fructose attached to it, and then it polymerizes the fructose to produce a secondary product called leaven. this is known to occur at 30 degrees Celsius, whereby the leaven polymer that is produced is therefore the reason why the ethanol concentrations were compromised during sucrose hydrolysis. So to overcome this challenge, we played around with different parameters where now when we increased the temperature to 37 degrees Celsius, we found that the ethanol concentration actually increased and gave us optimum ethanol yield. So basically what had happened there is that at 37 degrees Celsius, during hydrolysis, the secondary activation site was deactivated. As a result, fructose could not attach to the secondary site, and polymerization of the fructose was inhibited, which releases most of the fructose for fermentation by the bacteria, hence the high yields that were obtained. So the second biofuel that was investigated is biobutanol production by Clostridium saccharobutylicum. So with Clostridium saccharobutylicum is one of the most complicated fermentation process that happens in 3 different stages. That is acetogenesis, solventogenesis, and sporogenesis for the production of acetone, biobutanol, and ethanol. This pathway, fermentation pathway is carried out by Clostridium saccharobutylicum from the Clostridium species genus. So basically what happened during the initial stages of growth, the microorganism produces significant amount of acid. The stage is called the acetogenesis stage. Upon stationary phase, the acids that are produced are reassimilated back into the cells, from which they are reduced to produce solvents. So that is your ethanol, your acetone, and your butanol. Your butanol is produced at higher concentration compared to their counterparts. However, an increase in the solvents in the system basically results into inhibition of the cells, which then triggers the cells to sporulate and produce endospores to protect itself. Unfortunately, that's when fermentation ceases, which has been one of the major limitations of biobutanol production, and it had led to most of the biobutanol industries to close down, particularly the one in South Africa by the National Chemical Producing Company. So for biobutanol production, I also employ large-scale, I employed large-scale fermentation as well as small-scale fermentation. So for the large-scale fermentation, significant amount of the biobutanol were produced, and good volumes of the acetone and the butanol were also produced. However, the main challenge was that we had a significant accumulation of acids in the bioreactors, which could potentially lead to a lot of challenges. For if the waste needs to be disposed, it still has a high carbon footprint, which defeats the whole objective of the study. So currently, metabolic flux analysis work is being conducted to identify key routes that can be used to reduce the amount of acids or promote the recovery of the acids. However, reduction in the amount of acids that being produced can potentially result into higher yield of your solvents. The last process technology that was investigated is biomethane production from anaerobic digestion. So one of the biggest challenges of anaerobic digestion is that because of its high sugar content, during the hydrolysis stage, it results into increase in acids in the anaerobic digestion system. The accumulation of acids can further decrease the pH of the system, which affects the activity of methanogens. The methanogens in the system are responsible for methane production, which is the usable gas in the biogas being produced. So various research studies have implemented different strategies to reduce the amount of to reduce the acidification upon hydrolysis. This includes using a 2-stage bioreactor, increasing the operating temperatures, or supplementing your AD reactor with other compounds such as biochar, bentonite, or zeolites. My study focused on activating the methanogens, basically by increasing the methanogen concentration, the amount of methanogens in the anaerobic digester to basically be readily available to take up the volatile fatty acids as they are produced. In that way, it can combat a significant decrease in and anaerobic digestion. As a result, using confectionery waste in that manner, the microorganism, upon activation of methanogens, the microorganism was actually able to use confectionery waste without a decrease in pH and produce significant volume of methane. So basically, in this study, acidification of AD upon anaerobic digestion of confectionery waste was significantly combated. So finally, this study seeks to develop a decision-making tool that will basically allow policymakers to decide on the most suitable bioprocess technology for energy recovery, considering the production process in itself, being it a single strain fermentation for biofuel production or a mixed microbial community, such as anaerobic digestion that provides more stability in the system, or also looking into the microbial performance as well as the fuel properties in terms of calorific value, and that will also be dependent on the intended use by the confectionery industry or whatever industry that generates carbohydrate-rich waste stream, and also considering the environmental impact of the process technology and the overall confectionery plant or whatever plant that produces carbohydrate-rich waste stream. Thank you so much for listening.
Thank you, Carol, from University of Cape Town. Well, the next presentation is Christine Poffel. She's a Master in Science student at the Department of Environmental Science, School of Agriculture and Environmental Science, University of South Africa in South Africa. Well, the title is Biosorption of Mercury from Small-Scale Gold Mining Effluent using, oh my God, I'm afraid that I mentioned this term. Okay, thank you, Christine. It's your turn.
Thank you. Good morning, everyone. I'm going to start sharing my screen. Please let me know if you can see it.
Not yet.
Not yet.
Now, yes. Yes.
Now you can see it. Wonderful. So I'm looking at the biosorption process using, biosorption of mercury using Saccharomyces cerevisiae. So mercury is coming from small-scale gold mining effluent. Okay. Right. My presentation is divided into three. I'll talk about the background, the experimental results, and finally I will then conclude. So this is my background. Coming up. Right. Now, small-scale gold mining is a labor-intensive process that uses it's labor-intensive rudimentary process that uses simple mining methods such as mercury amalgamation. Now, mercury amalgamation is one of the greatest sources of anthropogenic mercury pollution. So it typically involves hand mixing your concentrated ore with mercury, and the mercury amalgamates the gold particles into a heavy sediment that settles at the bottom of the container. The sediment is then filtered from the solution, and from then the sediment is molded into an amalgam ball. The amalgam ball is then heated to evaporate the mercury, leaving behind a sponge gold. Now, the water remaining from concentrating the ore and the amalgamation process makes up the toxic tailings, which are then dumped into the pond. This is a typical pond. and the pond makes up the wastewater, which is a major source of environmental mercury pollution. So mercury pollution from the pond can happen in various ways. It can be through seepage, into underground sediments, by overflow from the pond into the surrounding air environment, and even through evaporation, because mercury has a low vapor pressure. This poses a risk to wildlife and human health. Okay. I'm going to my next slide, sorry. So mercury exposure has widespread effects on, sorry, I feel like I have lost my slide somewhere along the way. I can't, okay. So mercury exposure has widespread effects on humans and animals, and you find that it can lead to a host of diseases in humans that include renal dysfunction, autoimmune disorders, and also it can cause neurological dysfunctions. Right, I am missing my slide. Sorry about that. Okay, I found it. And then in pregnant women, it can cause severe birth defects, mercury intoxication, low birth weight in the developing fetus. Now, with over 100 million people around the world dependent on small-scale gold mining for income, it is now imperative that the remediation of the mining wastewater is implemented to curb the pervasiveness of mercury pollution. So biosorption is a bioremediation process that uses biological materials as adsorbents to remove toxic chemicals from wastewaters. It is becoming a preferred method of heavy metal removal from wastewaters because it is eco-friendly and sustainable. Saccharomyces cerevisiae is biosorbent that is able to adsorb heavy metals from wastewaters. It is readily and cheaply available in abundance as a byproduct of the fermentation industry. Now, the mechanisms are various, right? There are several of them involved in the biosorption process. These include surface adsorption, ion exchange, complexation, and precipitation through interaction with functional groups present on the microbial surface. Now, looking at the experimental results, the aim of my study was to assess the heavy metal content in the effluent, to determine the effect of yeast concentration, pH, and time of contact on the biosorption process. Also, I had to determine the optimized response for the process. I also identified the functional groups that are involved in the biosorption process, and I found out the impact of chemical treatment on the functionality of the biosorbent. From the pond, I took several samples using the random sampling method. And from there, after assessing the heavy metal content, I found that there was a very high concentration of mercury, which was 24,000 times above the recommended limit, showing that the effluent is a significant source of mercury pollution. When looking at the effect of contact time on the removal efficiency, the highest removal efficiency of 74% was achieved within 30 minutes, followed by a slow uptake for the next 150 minutes. And this short contact time points towards surface adsorption as the main mechanism of biosorption. And then looking at the effect of biosorbent concentration, The maximum removal efficiency of 75% occurred at 2% biosorbent concentration. Now, the increase in the removal efficiency from 0.1 to 2% is concentrated, is attributed to an increase in the number of binding sites. But beyond the 2% concentration, the rate began to reduce due to the shielding of binding sites caused by the screening effect between the dense layer of cells. Then looking at the effect of pH 4.5 gave the highest removal efficiency of 75.1%. And although pH has a significant effect on the bioabsorption process, there is a general range of optimal pH between 2 to 7 for metal uptake. Now, looking at our optimization, a full 2 to the power 3 factorial design was employed in order to determine the influence of yeast concentration, pH, and contact time on the adsorption process. So our statistical parameters for the 2 to the power 3, I used multiple linear regression analysis to evaluate the main effects produced by the interaction between the factors pH, concentration, and contact time. Now, each factor contributed significantly to the bioabsorption process. pH contributed close to 15.1%, yeast concentration 26%, and time of contact about 19.1%. And all of the effects combined contributed about 36.9% to the bioabsorption process. So our optimal conditions for the process were 2% biosorbent concentration, a time of contact 60 minutes, and pH 3.6 to give 75% removal efficiency, which amounts to about 18.3 parts per milligram of mercury removal. And then on surface chemistry characterization, this was to identify the groups that were responsible for the adsorption process. It was noted that there was a reduction in the removal efficiency when the carboxyl amine and SH groups were blocked, showing that they were the primary groups responsible for mercury adsorption. No decrease was noted when the phosphate group was blocked. And then looking at biomass pre-treatment, there was no significant change in the removal efficiency with the pre-treatment of bioabsorption. Okay, my conclusion is that Saccharomyces cerevisiae was successfully used for the removal of mercury from the gold mining effluent. And the results show that the yeast has significant bioabsorptive capabilities, and it's therefore a potential industrial biosorbent for removing mercury from small-scale gold mining effluent. And with its broad range of metal affinities, it can remove different types of metal cut ions, an especially useful property for wastewaters that contain a variety of metal ions. So the use of a spent brewer's yeast offers an economically feasible process that is low in operational costs and is environmentally sustainable. Thank you.
Thank you very much, Christine, from the School of Agriculture and Environmental Science from South Africa. Well, the next colleague, the next presentation is for Nazia Akhter. She is a researcher and PhD student in the Department of Computing Technology, Swinburne University of Technology, and in Australia. The title is Improving Human, the title is Improving Human Training with Wearable Full Body, IoT, Sensors, and Machine Learning. Welcome.
Thank Thank you, Professor. Yeah, so I'm Nadia Akhtar. I'm a PhD candidate at Swinburne University at Melbourne, Australia. So, as you said, my research is improving human training with wearable IoT sensors and as well as machine learning. So let me share my slides. I hope you can see it.
Yes.
Yes, thank you. Yeah. So my one is not as high-tech as other presenters and other colleagues presented. I think we are all familiar with training for human performance improvement. But here, when we are talking about human performance improvement, we are talking about performance related to physical activity for those people who are actively involved in physically intensive tasks. It can be in manufacturing industry, it can be in food processing industry, it can be in sports. Presently, for this kind of task, for performance improvement, these are heavily dependent on the human trainer who actually observe them and then design a particular training. But the problem is human particular skills cannot be actually improved by a trainer just by an observation. And each particular person has different need, different kind of skill improvement requirements. So this kind of training actually doesn't help to identify their improvement areas, as well as whenever this kind of training actually doesn't ensure the performance of that particular person when they're doing this kind of physical intensive task. So from this shortcoming, my research objective is to using full body IoT wearable sensors that will actually analyze the measurement of their body movements and identify their activities. And these will be related to the manufacturing or sports where they're doing various kinds of physical intensive tasks. And using the machine learning models, I'll detect the activities automatically and classify them. And using the different ML models, I'll be analyzing their activities and determine their performance. And then using the ground truth, I'll be analyzing the performance variation and where they can improve their performance. And this is the framework, and then we'll evaluate the framework using some real-world use case scenarios. For my research, we have taken 2 use cases. One is from manufacturing industry and another was from sports. So let's go forward. So yeah, before going to my other slides, the assumption in this research is that body movements can lead to a good performance whenever we are engaging in different physical intensive tasks. And IoT sensors can actually detect these body movements that will help them to identify their weaker areas. So what actually IoT sensors provides? So actually IoT sensors, in this case, we are using inertial measurement units. This is a kind of IMO sensors, which are very small and easy to use for this kind of real world scenarios, which has an accelerometer and a gyroscopes, and it provides different coordinates from the body, as well as different rotation angles that helps us to determine the body angles and the acceleration rate of different body parts, as we are saying that it's a full body wearable IoT sensor. So for this research, we have chosen a sensor that actually cover the whole body using 17 different IoT sensors in different body parts. So the proposed framework shows that this is an example how we'll use this framework in a real world scenario we are using here as a a meat processing industry where the workers will be doing different meat processing works and will have all these IoT sensors on their body. These sensors are already proven, so these are safe to use in real work environment. So when these sensors will be connected or implemented on their body, and after the calibration, we'll start recording their data. And in real time, in a computer, we'll be generating a 3D model from the kinematic data we'll be receiving through these sensors, as well as we'll be recording some videos so as a ground truth. So when these sensor data are transmitting in the computer, these will go through data processing and will do annotation, and also will compare this data with the ground truth. And the proposal is that we will do some real-time data processing in the cloud. So when we are doing the data processing, we'll identify the particular activities, and from the activity recognition, we'll actually can compare the performance of different persons. And from that, we can actually provide some personalized improvement feedbacks. So for that, we have chosen actually 2 use cases, as I said before. So these 2 use cases are, one is the meat processing. In meat processing, we are going for different kind of activities. One is called boning and one is called slicing. So in boning, you can see the workers are actually cutting meat from the carcass, and they are wearing all the sensors inside their suits. And in slicing, they're doing the same. And here we have taken different data sets. And for different data set, we have used different participants and as well as different knives with different sharpness so that we can identify the activities, their movements, as well as the sharpness of knife, that if the sharpness of knife is actually affecting the quality of their work or any kind of skills or body movements. So this is just a video showing how they're doing the work. Yeah, I think you have got an idea how we're doing it. So, and this is another case. This is also involved so much body movement in the sports. So here our use case is rock climbing. So in this scenario, you are seeing a professional athlete who are climbing this wall, which is 17 meter long. And she only took 40 seconds for this one, whereas the other participant, an average participant, takes around 2.5 minutes to 3 minutes to complete it. So when we'll compare her body movements with another person who is just a novice, we'll find that there is a significant difference in their body movements, which is actually contributing to their improved performance. So after collecting data, as I said, it is actually creating a real-time 3D models from the kinematic data we are getting from the sensors. So here is an example, like as you see, the person in the left side is actually cutting meat in the carcass, and we're taking the videos. And in the real time, the sensors are collecting data and creating a 3D model where it shows all these body movements and angles that is contributing to their task. Yes. So after that, we have classifiing this data using ML models. These are very complex tasks. So far, what we have found, the research exists. The research actually focused on very simple body movements like walking, jogging, running, these kind of activities. But for real world activities like that, where there are frequent body movements and different body movements, normally we found that the existing models are not that accurate. But in our case, we use for the sensors and the full body sensors, we found that our accuracy was 99%, which was really a surprise. And so it shows that it can actually detect every activities. When we are saying activities, it's like when the person is standing, when the person is cutting, when the person is doing stealing. Stealing is this kind of activity when they're moving their hands to sharp the knife. So it can actually recognize accurately all these activities together. And so far, we have done this activity detection and classification using the Ammon models. So our next task is to evaluating the performance from one person with another person using another activity model, and we are developing the specialized ML model for that. And after that, we'll use the ground truth. And the main another main significance of our research is that in current practice, the machine learning models use just one ground truth and finish the training. But for our case, what's our ground truth will be dynamic. Whenever there is a better performance, we'll use that ground truth against a particular person, and that training will be personalized and vary from person to person, because when we'll be comparing data with one person who is a male at particular age and has particular weight, when we'll try to compare with another person who is not at same body type as his or her, this will create a discrepancy. So for that, we'll compare the people's performance who are similar to their body type, age, or similar skill types. So this is so far we have done with this research. I think I'm a little early. If you have any question, please feel free to ask me.
Thank you very much, Nadia. Well, the time, I'm afraid that the time is over, but I would like to say something. Well, it's our pleasure to stay here participating in World Forum for Women in Science 2024, Envisioning Tomorrow. And I think that all of us appreciate this moment. We hear about Persana, about the supercapacity, Amruta, sustainable food production, Nisaf, a STEM game-based learning approach, civil engineering, Carol, about bioenergy production, Christine, bioabsorption of mercury, and Asia, IoT sensor, and to me, prefabricated system and buildings in order to size the footprint carbon. All of us work in different areas, but I don't know if someone else would like to be out another things in order to get the discussion. 1 minute, I think, Tanya, we don't have any time, right?
Yes, the time is up.
The time is over, okay. Well, well, I'm very grateful. It's my honor, it's my pleasure to share this space with you from any countries in any continent. Thank you to the organization.
Thank you for
Thank you.
Thank you.
It was very important and insightful, and we're wishing you a great day.
Thank
Okay.
you.
Thank you very much.
Thank
Thank
you.
you.